Greetings to everyone. Myself, Dr. M. Haryanand, working as an associate professor in the Department of Civil Engineering in Mari Lakshman Reddy Institute of Technology and Management. It is an autonomous institution and it is located at Dindukal, Hyderabad. I am handling the subject of surveying and geomatics for the second year civil engineering students. Today we are going to discuss the problem on height of collimation method or height of instrument method, then rise and fall method. So this problem has asked by the JNTUH in the year of 2016. Okay, now we can go for the given data. So the given data is the following consecutive readings were taken with a dumpy level and 4-meter leveling stuff on a continuously sloping ground at 30-meter interval. Okay, so that the data are so 0.680, 1.455, 1.855, 2.330, 2.885, 3.380 and 1.055. Here the value has been suddenly changed from, that is up to here it has been increased continuously. Okay, after that it has been suddenly decreased, so that this point is called change point, CP1. Okay, so this reading can be written in the foresight in the table, and this reading has been written in the backside column in the table. Okay, now 1.860, 2.265, 3.540, same here also. Suddenly the value has been dropped out from 3.540 to 0.835. So this is also the change point, so CP2. Okay, so here we have to write it as 3.50. This should be in foresight and this should be in backside. Okay, so the remaining values are at intersite. Okay, 0.945, 1.530, 2.250 meters. So this is our last reading, so we have to write this reading in the foresight, and this is the first reading, so we have to write it at the backside. Okay, now so for the understanding purpose I am drawing the details here, that is diagram here. So first we have placed the instrument somewhere here. Okay, and our first point is the benchmark point. So this is our benchmark. So over the benchmark we have to keep the leveling stuff. Okay, after doing all the initial adjustment we have to see the readings. Okay, so they have given that every 10-meter 30-meter interval they have taken the values. So our benchmark reading is 80.750. 80.750. Okay, so the first reading is 0.680. 0.680. Okay, now I need the height of instrument or height of collimation of this line. Okay, so our benchmark reading plus this height, if I am going to add, I am going to get the height of instrument position. So 80.75 plus 0.680, so 81.43. 81.43 meter is the height of collimation. That means after the leveling, whatever the line we have taken now, this line height with respect to benchmark is 81.43 meters. Now at every 30-meter interval they have taken the reading. So 1.45, so 30-meter interval. So every 30-meter interval, 30 meter, here another 30 meter. So next to 30 meter, so here it is 1.455. 1.455. Okay, this reading should be at back side. Okay, and next 1.855, and next 2.330, and next to that 30 meter. Here it is 30 meter. 2.885, 2.885, and with respect to this position our last reading is 3.380. 3.380. Okay, now after that the reading has been suddenly dropped out, so which indicates our instrument has been shifted from here to somewhere else here. Okay, now so now I am taking to somewhere position here. Okay, somewhere here. So after placing the instrument I have to do all the initial adjustment, so that whatever the leveling stuff kept at last point, same place I have to keep, and after doing all the initial adjustment at this change point position, I have to look the leveling stuff at the last point once again, so that whatever the reading I am getting now, that is my backside for the next point. So here what is the reading I am getting? 1.055. so this reading should be written in the back side, and this should be at foresight. So whatever the remaining points I am having now, that can be written in the intrasight column. So now 1.005, 055, then 1.860, 1.860, then 2.265, 2.265, and 3.540, 3.540. So this is our foresight reading, last reading. So foresight reading. After that the reading has been changed into 0.835. so again the shifting of instrument happened. Okay, so from here, after doing all the initial adjustment, what is the reading, that we are going to write it here. So at the change point 2, the backside reading is 0.835, 0.835. Okay, likewise the remaining point 0.945, 1.530, and 2.250 is our last reading, which can be written in the foresight. Okay, now the interval. So 30 meter. So here it is 30 meter. Another staff reading for 30 meter. Another one is 30 meter. Another one is 30 meter. Then next once again 30. So next another 30. Next another 30. Next another 30, then next another 30, another 30, and another 30. So the total number of pairs are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the total distance covered is 11 into 30 meter. So that 330 meter they have taken the level, and here they have mentioned gradient. Okay, now so the gradient is nothing but the leveling distance, RL difference between the first point to the last point divided by the total distance covered. Okay, now we should go for first question. Okay, carry out the reduction of heights by the collimation method. So now whatever we have drawn now here, we can convert this diagram in the form of tabular column. Okay, now so the table consists of serial number, backside, interside, foresight, height of instrument, reduced level and remark. Okay, now so serial number, first one. Okay, our first reading is 0.680. So 0.680, that should be in backside. Okay, here they have given the data as 80.75 meter is the benchmark reading for the first. You can write it as the benchmark. Then second reading 1.455, so that should be written in the interside 1.455. Next 1.855, 1.855. 2.330, 2.330. Next 2.885, 2.885, and next 3.380. So that is the last reading, so we have to write it in the foresight 3.380. So next reading 1.055, this is change point, so 1.055 should be written in the back side. And now in the remark we have to write this is CP1. And next reading 1.860, 1.860, then 2.265, 2.265, and 3.540 is the foresight reading. So 3.540, which is at foresight. Next to that 0.835, this can be written in backside 0.835. After that 0.945 should be written in interside 0.945. After that 1.530, so 1.530 should be written in interside, and last reading 2.250 should be at foresight 2.250. So here this is CP2, change point 2, and in the serial number 2, 3, 4. Okay, now we have to calculate the reduced level and height of instrument. So first, up to this, the reduced level height of instrument becomes 80.75 plus 0.680, so it becomes 81.43. 81.430. Okay, now so 81.430 minus this 1.455 gives the land value, land RL value. Similar way, 81.430 minus 1.855 gives this land value. Okay, similarly here also. So likewise, so 81.430 minus 1.455 gives 79.7975. that can be written in the RL. So 79.975. Next, 81.430 minus 1.855. So 79.575. Next, 81.430 minus 2.330. So 79.1. So always we have to take 3 digits after the point. Next, 81.430 minus 2.885. So 78.545. 78.545. Next, 81.430 minus 3.380. It gives the answer of 78.05. So 78.05 is the land value here. .05. Okay, so if I need height of instrument for the CP1, how I have to do? So 78.05 plus this reading 1.055 gives the height of collimation here. So 78.05 plus 1.055 gives the answer of 79.105 is the height of collimation or height of the instrument. So hereafter, how the way we have to calculate our land RL? So 79.105 minus 1.860, 79.105 minus 2.265, likewise. Okay, so 78.050 plus 1.055 gives 79.105. This is the height of instrument for the CP1. Now 79.105 minus our corresponding reading. Okay, so first to 1.860, it gives the value of 77.245. 77.245. Next, 79.105 minus 2.265, it gives the answer of 76.840. Next, 79.105 minus 3.540 minus 3.540 gives the answer of 75.565. 75.565. Now come to this diagram. So here the RL of the point is 75.565. So now the height of instrument for the CP2 is 75.565 plus 0.835 gives the answer of 76.4. So 76.4 is the height of instrument. Now if I need the answer for this RL, this 76.4 minus corresponding reading I have to, corresponding intercept and the foresight I have to give. Okay, so now the answer is 76.4. this is the height of instrument for the position of CP2. So 76.400 minus 0.945 gives the answer of 75.555. Next, 76.400 minus 1.530, 74.87, 74.870, and last reading 74.400 minus 2.250 gives 74.15. So up to this booking of reduced level and booking of leveling reading and the calculation of reduced level is over. Now we have to do the check whether our calculation is correct or not. For that, the formula for the height of instrument method is sum of backside minus sum of foresight should be equal to last RL minus first RL. Okay, so now we have to add sum of backside reading. So sum of backside readings are 0.680 plus 1.055 plus 0.835 gives the answer of 2.57. So I am writing here. So 2.57. So 2.57 minus sum of foresight. So sum of foresight is here 3.380 plus 3.540 plus 2.250, 9.17 minus 9.17. So which is equal to last RL minus first RL. So our last RL is 74.150. 74.150 minus first RL value 80.75. 80.75. So the difference becomes, so 2.57 minus 9.17, we are getting minus 6.6, minus 6.6. So here at right hand side 74.15 minus 80.75. So that also we are getting as minus 6.6. So that our left hand side which is equal to right hand side. So the result is correct, and whatever the calculation we have done, that is also correct. Thank you.